Hello and welcome to the Educators podcast. I am Vishal Bagaita, the founder of Educator and your host for this podcast. Educator is an online marketplace where students can get access to video courses, downloadable documents and tutors to help them study for their exams. The Educators podcast is an opportunity for you to learn more about what goes into creating the learning resources on the website. You can hear more about our latest resources and discounts by registering today at educator.com and signing up to the newsletter. In our fourth episode, we are joined by Robin Andrews, an experienced educator specialising in maths and computer science. In this episode, Robin tells us why he has taken a project-based approach for his courses. I hope you enjoy this episode. Hello, Robin. Thank you very much for joining me today on the Educators podcast. Please, could you introduce yourself, providing some insight into your experience in the education sector?
Hi, Vishal. So basically, I started teaching formally back in 2006 when I qualified from the College of St Mark and St John in Plymouth in Devon. And that was with a degree it was a B.Ed actually, B.Ed Hons, in mathematics and computing education. Although I did a fair bit of computer work, my focus was mainly mathematics for the first few years of my career. So I taught in various different settings, some of them quite unusual, just the nature of the jobs that I got really. So I taught in the small school in Devon, which some of you may have heard of. It was a very small school. It had about 25 pupils, I believe. And after that, I taught in a special unit for children with emotional and behavioural difficulties. And then I've taught in an independent small school again in Devon. So I've had a fairly unusual career in some senses. I haven't done a lot of work in mainstream schools apart from supply work, which was always an interesting experience. During that time, I started doing home tuition, and quite successfully. I had quite a few students coming to me for extra GCSE tuition mainly. Did that for a number of years. And then I think it was about 4 years ago now, I was asked to teach computer science at one of these alternative schools I was teaching in. And having been a programmer as a kid and really loving computers, it kind of reignited that kind of, that passion really for programming. So I kind of got right on board with that and, kind of studied the curriculum myself, made sure I could deliver it, and then delivered computer science GCSE, and then started offering that as part of my home tuition service as well. And then over the past couple of years, I've had several people approach me asking to do online tuition for computer science. And that includes A-level as well. And so there's been a couple of contracts I've had in China, and that's been very interesting using different classroom, virtual classroom technologies. When there's a potential language barrier, because some of these students, some of them were very fluent and some of them weren't so fluent. So we had to find ways of communicating ideas that weren't purely linguistic. So that was very interesting. So now I do a whole mixture, probably more online teaching now than face-to-face. And recently got quite serious about my business called CompuCademy. So I registered the trademark, and I'm now focusing exclusively on computer science rather than maths, and just really want to make myself available as a support in terms of offering resources and tuition and teacher training as well, and courses for students. Just making myself available for anyone that wants to learn computer science, whether student or teacher, and helping them to learn those skills which they don't always have access to in schools. I mean, there isn't a great coverage in UK schools for computer science, and I think some people aren't given the opportunity. So that's my goal really, is to help people that really want that kind of extra support with digital skills, and particularly programming. That's, there is a lot of different topics within the syllabus, and programming plays a significant part. And I think in some ways that's one of the areas where having input from a tutor, for example, or doing a video course can be especially beneficial, because it's not so much a case of just going and looking up the facts in a textbook, but there's actually processes. Like with mathematics, actually, there's processes that you need to learn, how to think algorithmically and how to, actually write a computer program that does what you want it to do. And I think things like that, you can definitely benefit from, online courses and tuition. So, that's kind of what I'm about. Hopefully that covers the question.
Thank you, Robin. And in terms of the transition from teaching in a school setting to tutoring, Did you change your approach in any sort of meaningful way? I mean, clearly there's a change in the audience. How did that manifest in your teaching approach?
Well, it's interesting because I've always had this attitude towards my students of how to put it, kind of mutual respect. So I've never been one to kind of lord it over my students. I've always tried to form more kind of friendly, cooperative relationships with them. And that's been possible because I've worked in these alternative environments where there's generally not been 35 kids in a classroom or whatever. And in fact, when I have been in those situations doing supply work, I've found it quite challenging. And that's partly because I really value this kind of mutually respectful relationship. So in that sense, I'd say it hasn't changed much. Certainly with a smaller audience, one-to-one, or sometimes I teach small groups. I've got an online group at the minute. I think it's got 7 students in it. So, the audience is smaller sometimes, but it's the same approach. It's like you're building rapport, being respectful, kind of meeting students exactly where they're at. And for me, the smaller the group is, the easier it is to sort of work out exactly what is the next step, in your learning journey. It's like you're here, you need to get to there. What is getting in the way? You can do that with 5 kids. It's very hard to do that with 30 kids. Yeah. So, but in terms of my actual approach, no, I mean, like I said to you before the podcast, I kind of aim for clarity and friendliness. They're my 2 kind of characteristics that I try and embody, and whatever context I'm in, I try and do that.
You mentioned earlier on that you teach to students in China. Can you tell me a bit more about how you have overcome some of the linguistic challenges that you mentioned? What kind of techniques do you tend to use there?
Well, with the Chinese, they can be quite reticent sometimes, and that's partly just a confidence with the language thing and partly a cultural thing. So I found that after some initial attempts at establishing lively conversations, it was quite hard work to make that happen. So we kind of resorted to a default of me being quite active and then responding via chat. So they were quite happy to chat. And the great thing about using Adobe Connect, which was the tool that we used for those lessons, is that you can have several different pods on the screen. So a very common setup during the lesson would be I'd have, say there were 4 kids in the lesson. They'd each have a pod, and I'd say, right, we're going to do this exercise. We're going to do some pseudocode for this algorithm, type up the pseudocode, and then while they were typing, simultaneously, I'd see their work, coming on screen in front of me, and I could give instant feedback to the individual about how they were going. Right. So that was really useful. Just so making use of technology that allows multiple simultaneous, conversations or text sharing was very helpful.
Okay. And then just moving on to the video courses, which of course we're hosting on educator. Those will be covering GCSE Computer Science in the first instance. Can you provide an overview of how the syllabus is structured at GCSE level?
I can. It really varies from board to board, to be honest. So I've taught Cambridge International, I've taught EdXL, OCR, and AQA, and they're all different in different ways. So taking OCR, for example, I've got the syllabus in front of me. I'm teaching this currently. So there's actually 3 components, but one of them is the project. And now the project has actually been dropped due to some issues they had a couple of years ago with some cheating. They realized that actually the project is too fraught with potential issues to be viable. That was the decision that was made. So we're in this funny situation at the minute where the students have to complete a project and a sample of their work is submitted to the exam board, but none of it is assessed. So that's some of the syllabus, still has to be completed. Quite an interesting arrangement. But the other 2 components, you have computer systems, which is more theory and hardware. Actually, it's a mixture really of factual knowledge, like we were saying earlier about factual knowledge versus process-oriented learning. So there's some basic factual knowledge, like, you know what the components of a CPU are, how system security works at a basic level, stuff like this, some of the ethical and legal concerns. But there's also process-oriented stuff, which is more like the mathematics of computer science. So you need to be able to convert a denary number to a hexadecimal number to a binary number and calculate storage space for different types of data, so images and sound files and things like this. So there is a slightly mathematical component which kids can't get away from. They're still going to need to do some maths. So that's the first unit, computer systems, which basically means hardware and maths in a nutshell, yeah. And then you've got computational thinking and algorithms and programming. That's the name, computational thinking, algorithms and programming. So that covers algorithms, some of the standard ones like searching and sorting algorithms, and then programming techniques. There's a module on producing robust programs. Mm-hmm. That means things like validation. and programs that aren't going to crash. So you kind of work out potential problems in advance and cater for them. Computational logic, translators and facilities of languages. This is quite a high-level description here. This is just from the syllabus. And data representation. So again, that would include some mathematics in terms of binary and things like that. But it's all sliced up in different ways. It's basically the same content. There are some slightly frustrating variations between the syllabuses where there's a topic in AQA that's only in AQA, and you have to kind of deliver that and find the resources for that, and it's not in the others. But it's also quite interesting having the overview of teaching multiple syllabuses and seeing where they're similar and where they're different.
Do you think that the manner in which it's sort of split up is helpful for encouraging students to carry on with it at A level, in line with some of the objectives around the STEM space?
I think there's probably multiple parts to that question, to be honest. So A level, I do think A level is pretty good, actually. It's pretty thorough. And I think GCSE leads into it quite nicely in terms of it's like a mini version of some of the bigger topics. So you cover algorithms in GCSE, and then you cover them in much more depth in A level. And there is this quite a nice progression between the two. I think there is a bit of an issue with uptake, partly because people, I think, perceive computer science as being quite difficult. And to be honest, that's probably a fair assessment because it's a science. And I think maybe people haven't always made the connection that it's on a par with physics, it's on a par with biology and chemistry. It's an in-depth, it's a rigorous mental discipline, so it is difficult. And it does require a certain mathematical competence as well. So I think I just mentioned there A level. So yeah, I think A level is great, and I think the progression is quite good. But in terms of STEM, now I think this is quite an interesting one because I don't think there is anything like enough integration between topics. So for example, in Python, there's this whole business about data science, right? And there's a massive selection of careers that involve analyzing data and processing data in different ways. And Python as a programming language is absolutely excellent for that kind of stuff. There's all kind of packages you can use and different techniques and tools that make that kind of stuff really simple. So to me, it seems like a really obvious candidate if you're doing something in physics or you're doing something in biology or chemistry that involves data, statistics, anything like that, and also with maths, of course, to be using programming languages such as Python to enhance that learning. Now, this is not new. So for most of my career teaching maths, I made a lot of use of handheld graphics calculators, in particular Texas TI-84s, which were programmable graphics calculators. And they were brilliant. So, when you were learning about data handling in mathematics, you could easily draw a scatter graph, or you could do a histogram, and you could very easily process data and focus on the actual high-level concepts, rather than the nitty-gritty. Because I think sometimes, I know a few years ago, I think they banned calculators in primary schools. And I think that's a terrible move because sometimes you're working on calculation. Sometimes you're working on high-level concepts where calculation is just a small component. And if you constantly have to split your mental energy between those two realms, it's not great from my point of view. So for me, using technology is brilliant for learning science, maths, and probably other topics as well, like stuff about PHSE and being a citizen and understanding how democracy works and statistics around democracy, anything like that. The potential is vast, So another thing with these calculators is they were programmable, and they had a language called TI Basic. They still do, actually. You can still get them. And it's interesting because the programming language TI Basic is almost identical to the pseudocode that you have to learn in the computer science syllabus. So there's a difference between programming languages and pseudocode, which is kind of like like a transferable language. So whatever language you're going to implement an algorithm in, you can write it out in pseudocode, which is like halfway between English and a kind of generic programming language. So the programming language for the calculators is very similar to what you would need for the GCSE pseudocode component. So the way I see it, why not get used to writing programs on a TI-84 graphics calculator? I do that myself. And you could argue it's a bit outdated, in which case go for Python. But I see no reason not to be doing massive amounts of the maths and science curriculum using Python programming. It just doesn't make sense to me not to be doing that.
You alluded to projects as being one way of learning as opposed to being focused on factual knowledge type learning. And I guess I'm just curious of how those two approaches might affect the structure of the course that you've created.
The thing about projects is they give you a kind of a focus So rather than learning lots of individual factoids in isolation, you actually have a context within which you're learning those, and then you have a goal to work towards. Okay, so it gives you a focus, it gives you a context, and then you get this real sense of achievement, even though it's quite difficult sometimes to kind of pull together all those different threads that you need in order to achieve the project goal, whatever it is. In this case, it's a game, like writing a guessing game. But then once you've actually done it, you'll find that you've done some really deep learning. There's been lots of research done to show that having a project-based approach massively accelerates learning. And it's all about this context thing. So, it gives you a reason to remember the things. If you don't have a context, you can be thrown loads of facts and you can try and, take them in, but they don't really mean anything because you haven't got any application for them. Whereas if you almost completely invert that process and you say, right, I know nothing, but I know what I need to do. So then you go off and you specifically search for and select the components that you need to achieve your goal. And it's just been shown to be a much kind of more powerful learning process, really, than just having this kind of linear going through a list of topics approach. And that's what I'm aiming to do with these mini courses. And eventually, I'll do like a whole course that does as much of this as possible for the GCSE. Obviously, there's some aspects that don't lend themselves very well to this approach, but certainly with the programming and some of the other parts as well, it makes a lot more sense to me to use this approach rather than just, learn a sequence of facts.
Okay. And can you tell us about how you have structured the components of the course as a result of what you've just described?
Okay, so we've introduced one aspect that you need. So, for example, the game needs random numbers. So we've got a video about how to create random numbers using Python. But then rather than just giving you the information and hoping that it sinks in, we've said, well, go off and, write this code into a Python editor, run it, change some things. I always say try and break the code and then fix it again. Change some numbers, make it your own. So that's the approach, really. We kind of show you one way of doing stuff, and then you go off and you do it in that same way, typing it in. There's no point ever in copying and pasting stuff when you're learning to program because you're not actually programming. It's an active process, right? So you go away, you type it in as we've given it, but that's just the beginning. And I'm hoping that most students will be willing to put in that little bit extra where they're not happy with just, okay, I've done what it said, but it's like, okay, now I really want to understand that. So I'm going to change some things. I'm going to try and maybe use that technique in my own side project, which is kind of related to the main project. So that, that's one part of that. And one thing I mentioned in that particular course is that it's a good idea to have two files open at a time. So we have the file, which is like the final game that the student is going to be writing as a result of completing this course. But you also have another file where you try things out. So say you're working on random numbers, then in one of your files, you're literally just doing all these little snippets. Like, can I generate a random number between 1 and 10,000? Can I generate a random number that has 2 digits or 4 digits or something like that? That's all kind of like separate. It needs to be built into the final project, but it's kind of done as a preparatory exercise, if you like. And then once you've kind of mastered that and you know exactly how you want to do it in the final project, you can then put that code into the second file, which is like your project being built, what your final file is going to be.
That's helpful to understand the approach you've taken. I just want to move on now into the process that you use to create the course. It'd be useful if you could give some insight into how you split your time between preparation, creating the materials, and editing the materials.
Okay, well, first of all, I'd say it's surprisingly large amount of time involved in creating these things. There's a lot that goes on behind the scenes. Probably the biggest part is actually writing the code for the game. So I've got a game like this, Bulls and Cows, and I've got other games in the pipeline, such as a game called Chomp and other things like Hangman and Tic-Tac-Toe, or what we call Noughts and Crosses in the UK, don't we? All these games. I mean, that's going to be my main way into the programming, is like using a game that hits exactly the right syllabus objectives. So it's kind of like it's linked to the syllabus, but it's not going through systematically point 1, point 2, point 3, because that's not how the learning really works. So it's kind of lighting two candles with one match, if you like. So we're hitting the syllabus objectives, but we're also learning how programming really works, which is this kind of integrated experience of, accessing the information I already have, researching the information I need to make it work, moving between kind of different levels. So there's that. And then, coming back to your question, I'm not quite sure how I got over there, but there we are. The program itself, right? So we need to write the code. I need to write the program in a way that is not just correct, but also at the right level for the students that I'm teaching. So there are all sorts of ways of writing code when you're a more experienced developer that are incredibly efficient and almost like poetry. You kind of slice away anything that's kind of superfluous. But if you do that too early, then in terms of another human being understanding how it works, they're not going to have a clue unless they're really experienced. So you have to kind of find this way of writing code that's not just correct, not just good code, but also very easy to understand why what is being done is done. So we don't use shortcuts and things like that. So there's all those considerations. So I sometimes have to kind of take my first version and kind of rejig it for the audience that I'm writing it for. So that's one aspect. So there's actually quite a lot going into just coming up with the solution, then taking the solution apart and breaking it into steps and kind of backtracking to the point. It's like, okay, so this is what it looks like in the solution, but what are the steps that I need to get to the point where that component within the solution has been created? So you have to kind of step back and, the most basic part of that component, build back up so you've got that full component, and then put that component into the final product, if that makes sense.
Yeah.
So that's all the preparation in terms of writing the code and then forming individual lessons around each part of that code. Then, like you say, there's stuff like editing and, actually recording the videos and the screencasts. And then producing the documentation, actually producing the files. So I use a thing called markup, which I strongly recommend anyone that's making content learns about, actually. It's a very, very popular format for writing text documents where you use all these syntax shortcuts. You use like a pound sign. So used to talking to Americans these days, use a hashtag for H1 or two hashtags for H2 for like a slightly smaller heading. And you use double asterisk for bold and single asterisk. I always get them mixed up. For italic. And you just have these shortcuts. So I create my lesson documents using markup and then put them onto my site and they get rendered as HTML. Getting a bit technical here, maybe not necessarily students or parents needing to know about this side of it, but just getting a bit technical there. But yeah, all of that, it's a long process and there's lots of different components.
Right. I think that was really interesting to learn about the approach that you take, because it differs from the traditional model that some of the other course creators on Educator have taken, which is generally about following the specification to a T in the same order, and then just creating videos that address each of those. I think what you're talking about is covering off the same material, but as you described, just presenting it in a format that lends itself for a project for students to follow. And I think I was really intrigued by what you talked about early on in that answer you gave, which is about creating games. We know games are fun, and finding a way of making learning fun for people in this way seems to be an impactful way of teaching for you as well.
Yeah, I think motivation is everything, to be honest. I think because learning, certainly anything process-based, it might be different with facts if you've got a good memory or something, but certainly anything process-based, it's an active process, and it's very hard to be active about something you don't care about, right? So motivation is pretty important here. So anything that can be done to increase that. It's interesting. You don't want to pamper, I suppose, too much to people's whims. I've taught over the summer, I've taught in a library club, and we've used Scratch. And I've noticed, you probably know what Scratch is. It's like a visual code builder, yeah? And I've noticed there is a reluctance, because that's so engaging, there is a kind of reluctance to move from that to the sort of slightly more serious world of actually writing lines of code. So, yeah, you've got to kind of nudge people in the right direction, but it's got to be engaging, and it's got to be meaningful. And one of the kind of instant ways of providing meaning is the kind of the playfulness of it. Playfulness is intrinsically engaging. So playing games, problem solving. I always say writing a program is a bit like solving a puzzle or like a murder mystery or something, a detective novel. There is this kind of playful puzzle solving element to it. And if you can kind of really accentuate that and get kids on board with the fact that this is fun, even if it's difficult, it might be a little bit challenging, but it's rewarding and it's engaging, then to me that's crucial.
Of course. a slightly sort of different perspective on this, which I did hear, was the idea that what if A-level computer science was rebranded to a course that was called Learn How to Make Your Own Video Game? Do you think that would attract more people?
It's an interesting question, because having said what I've just said, right, I'm now aware in my mind of the fact that some people, they will just play video games unless you actually tear them away from their console. So I don't know. I think there's probably a balance to be struck, to be honest, between pampering too much to people's comfort zone in terms of, especially with teenagers, because teenagers, there's so much change going on in their lives, right? That probably one of the reasons that they seem resistant to your suggestions of more change is that they got so much going on already. So they might seem like really conservative, like don't want it, whatever, But in fact, everything about them is changing. Their brains are being rebuilt from the ground up. Their bodies are changing. Their whole personality is changing. So there probably is some resistance to change. Why am I saying this? I'm sure there's a good reason. So yeah, not pampering too much to, I just want to play video games, and maybe giving them something that's a little bit more kind of career focused, or a little bit more, at least expanding their horizons. So if all they've ever done is played video games, and now it's like, oh great, I can go to college and do video games, then I'd want to challenge that personally. So there's a balance to be had. To be honest, I'm not quite sure where I stand on it, because having said what I just said about motivation, I'm also into rigor and achievement, and not making things just, not sort of staying forever in the playground, as it were, but actually dealing with real world issues.
Of course. And just sort of wrapping up, you talked about the course that we have on the site only addressing one part of the specification. Can you tell us what plans you have to build on this?
Okay, so all the ones that weren't hit by that first course, I'll go back and I'll make other courses that hit the other ones, first of all. I know, for instance, for OCR, you need to know about databases and SQL, which you don't need for some of the other ones. So I'll make a game based around using databases. And what I've got an idea for that is actually some kind of simple card game where we store card data in a database. It's a little bit contrived, because at the level we're working, you probably wouldn't actually use a database for this task, but we have to find some way of bringing database into our learning. And again, making it meaningful. So if we can make it as meaningful as we can by making a game from that, then great. So yeah, probably a simple game like blackjack or something like that, or even just creating a deck of cards in a database and then accessing it by suit or by value or something like that. So I've already I've actually started on that. It's kind of percolating in my mind. I've made a start and I've forgotten about it for a couple of weeks, and I'll get back to it. So that's one thing, is to cover all of those, make sure all of the individual items are covered, and then eventually probably building a course that covers the whole of, say, the OCR GCSE syllabus, and includes perhaps, I would say, to get confident and competent at programming, you're probably going to want to cover maybe 4, possibly 5 of these projects that you've kind of worked through. So you're no longer just, I know some students study Spanish GCSE at school, and they come out and they can say, this is my name and I live here and I want a beer. And it's like, you've got to get to a slightly higher level than that. So, doing 4 or 5 of these projects will give you that kind of depth of language experience, as well as all of the sort of less kind of process-based stuff, like just the facts you need to know about network topology and how the CPU works, and like I say, some of the security issues and ethical questions that come up around computing in the modern age.
Great. I really look forward to playing those games and learning how to program them. So thank you very much, Robin. I've really enjoyed this conversation. So thank you so much for your time.
Okay, thank you, Vishal. I enjoyed it myself.
I really enjoyed Robin's enthusiasm and hearing about the project-based approach. Games seem to be well suited as motivational tools, as ultimately you want to be able to play them once created. It's great to have the first one uploaded, and I look forward to seeing what games Robin uses to motivate learners in future courses. If you are interested in uploading materials to Educator, please do reach out via the website contact form, social media, or a trusted email to info@educator.com. You'll also find information about how to get started on Educator in the guidance part of the website. Don't forget that you can find links to Robin's courses in the show notes and social media posts that accompany the release of this episode. If you've got this far, thank you very much for listening. Being in different locations necessitates the use of Skype or Zoom. I hope you can ignore the minor artifacts that can arise in these types of recordings. Finally, the last message, but by no means the least. Please do like and share the podcast. Knowing that the podcast is scoring well with you, the listener, gives me the motivation to create more episodes. Don't forget to hit that subscribe or follow button too.